Hello YouTube, De-bodgery here. Welcome to EV Components Review. Yeah, I'm going to try a slightly different format from now on with my videos. Try to keep the macros shorter so that they all go together much more quickly, because otherwise it gets really long, and try to break them up into more logical sections. So this one will cover just the logic board. You know, the daughter board is of lower interest. But anyway, so here is the FarDriver 96850 logic board, and this area over here is all your DC to DC components. So battery voltage comes in over here, the buck chip right here, which is made by a company called Uni-U, and that is a U3018. It's good up to 180 volts and 600 milliamps. And anyway, yeah, so this is your buck chip. Here's your inductor. Here's your output filter caps. You got a couple of those. You've got some ceramic caps on here for dealing with high frequency noise on the battery bus. So kind of a decent DC to DC on here. Probably good for about 600 milliamps, since that's what the buck chip is capable of. But yeah, there's your DC to DC. This is a commodity item. There's a half a dozen companies, if not 50, that all make a buck chip very much like this. Whichever one you get, you just solder it in place and it'll just work. Because yeah, the pin for pin is the same, the amperage, the voltage range is all the same. It's a very much commodity part. So in fact, this one's made by Uni-T, and the next one you see is made by Joe Bob's IC company. It's no real surprise. Don't recognize this kind of swoopy eye logo on this 7805, but again, very much a commodity part. You can get 7805 linear regulators from hundreds of different sources. Probably 30 or 60 different manufacturers make them around the world. Unlike the DC to DC converter, which you need a couple of pretty good sized caps to clean the noise up. With a linear reg, you only need a little one, so that's an advantage for a linear reg. Kind of changing my opinion about linear regs. Over here is the 3.3 volt linear reg, and again, another small filter cap for that one. If anybody can tell me what CHUE is as far as a data sheet, that'd be super cool. I was not able to find that, so please post that in the comments what that is. Don't recognize that little kind of like a wave logo. What is that, a bird's head or something? I don't know. Anyway, couldn't find the damn part, so don't know anything about it. Why FarDriver doesn't just put 4 pins in there and make them tall enough to extend beyond the potting. Yeah, kind of wish they would, because that basically means that people that aren't me, can do similar things as me, would basically brick their controller and never be able to do anything about it. And of course, being that this is Chinese, sending it back to FarDriver is basically never going to happen. So you basically are screwed if the flash goes wrong and you brick your controller. Whereas if you have access to this thing, which is not rocket science, then anybody with an ST-Link can reflash the CPU with the firmware, and probably you're back in business again, without having to depot everything like I had to do. Anyway, you'll notice that this says it's a giga-device CPU, and it's a GD32F103. It's pin for pin, registry-wise, speed, memory, all that kind of stuff. Exactly the same as the STM32F103. It's just simply the giga-device part. So maybe the real ST micro part was constrained at the time, and so FarDriver could get the giga-device. I don't know. That was the problem that EBMX had with the X9000. They couldn't get the STM32F4 or 5, so they had to use the giga-device part as a result. If that was a problem, then KO Moto controllers would be just absolutely kicking EBMX controllers' asses, and actually the opposite is true. X9000s are absolutely stomping all over anything that KO Moto is making. And the Rush controllers are blowing up, going thermonuclear, while the X9000s are not. Max regen, max field weakening, and they just take it and they run. Do that with a Rush controller or an F-Spec controller, and they go up in flames. Yeah, good design versus bad design. I wonder why that works that way. I've only been saying that for, 10 months now? Yeah, definitely a clone CPU, did not change anything at all for the performance of the X9000 versus anything that Komodo has done. Komodo just simply likes to cast mud and shit all over everybody else who's making far superior products to them. All right, and Komodo is flat out made by FarDriver. You'll never hear Chrissy ever deny this or say yes or no for it. In fact, I forget who it was. I think it might have been Ian that said, well, we never said we were FarDriver. It's like, yes, you did. You've denied it over and over again. And then he slipped and said, yeah, we do FarDriver. It's like, yeah, no shit. Anyway, so let me talk about current loops or current concentrators. So you can see that this is a bunch of little concentric rings or layers. So iron, it likes to maintain whatever magnetic state it was already in. And in the case of like motor laminations, or rather motors or transformers or current loops, you need to be able to change that rapidly. Because if you can't, then you can't sense current properly because this reacts too slowly to current changes. You need it to respond quickly, and iron's desire to stay in whatever magnetic state it was already in has to be overcome, and you do that by making many thin layers. So the exact same thing is done in motors, the exact same thing is done in transformers. Just many thin layers allows you to pass AC alternating magnetic fields through that iron, transfer it over to whatever other place it needs to go, and then you don't have the buildup of magnetic fields resisting quite so much, and that's kind of how you mitigate that. So somebody on Facebook named Vasily asked me about these Halls, and was not able to find the data sheets on them, but they say C1612 on them. So Vasily, C1612, that's about all I can tell you. I could not find the data sheet for the darn things, just like I couldn't find it for the CHUE 3.3 volt linear regulator. So if anybody knows what the data sheet is for those two parts, please post it in the comments below, and I'll just add it to my collection. We'll move on from there. So these gate drivers, so you can see they are a U3216. So that's made by that same company as the buck chip Uni U. And they are rated for 600 volts on their gate drive side. And they are powered by anywhere from 3 volts to 20 volts on their DC side. And they're getting powered by this little 12 volt DC to DC converter right here. So that's right smack in the middle of their voltage range. Anyway, extremely common part. You can find pin for pin compatible gate drivers from a dozen different sources. Again, a very commodity item. These ones are made by UniU. Yeah, I forget what the ones are like on, say, the Komodo controllers, but yeah, it's an extremely common gate driver, fairly low current, very, very inexpensive, very cheap, made by a dozen different sources. So yeah, if you can't find it from one source, just buy the next one and put it on your board and it's going to work. Same thing is true for the LM2901, extremely common quad op-amp package. So like this one here, you see the ON logo, that's from onsemi. But when I Googled for the data sheet for it, which I already had anyway, I came up with the TI data sheet for the exact same part. And in fact, there's several quad op-amp packages that are all interchangeable with each other. So the LM339, LM2901, and LM139 are effectively all the same chip, all the same pinouts, all the same specs, everything like that. And again, it's another part that's made by dozens of different sources and manufacturers. So everything here about FarDriver is very generic, very easily available parts from dozens and dozens of different sources. Nothing here is particularly specialized. No Infineon, gate drivers or something like that, which would be a much higher performance, more constrained component. Everything here is very, very generic. I don't know what you want to call it, jelly beans parts. Very easy to find, readily available stuff from most any source. Any supplier for electronics would have this kind of stuff from a dozen different places, and they would all work interchangeably. So, very common for Chinese stuff that they're going to just go for the most, lowest common denominator possible, which makes everything cheap and easy to get and readily replaceable from a dozen other sources. Whereas if you go from more Western things, more specialized, better, higher performance things, they're not going to use generic parts like this. They're going to use more specialty components that are harder to get, more constrained, and as cost, but also as performance and reliability. Whereas parts like this, they're going to operate more slowly. They're not going to be able to deliver as much current. Their capabilities are more limited. But, you know, hey, for lower end Chinese stuff, something like this or like a Komodo works just fine for that, because you're not really expecting very much. They're not that good anyway. So, you know, this is basic FOC. Its ERPM limit is much lower than, say, like a VESC controller. You know, I forget what this is. It's like, say, 60,000 ERPM. It's a tongue tangler for sure. Whereas, like, say, a VESC controller is 100,000 ERPM or 150,000 ERPM. So you need much better components for that kind of thing to be able to reach those kinds of speeds, you know, and switching frequencies and things like that. So, yeah, cheap parts mean slow. Good parts mean fast, better precision, stuff like that. And everything here is very, very jelly bean. Let's look at the back side of this board. And then we're going to call it on this one. You'll notice this witness mark on here on the solder pad. So this is where the studs for the power stage press against the logic board. When I run my spooge over there, there is no ridge. That's literally just marking on the circuit trace. Whereas if you look at, like, say, the Komodo controllers, no, it's actually compressed because they crank those screws too tight, and it's why it is that, like, say, that one battery minus stud is literally sheared off on 2 out of 2 Rush controllers I've taken apart. It's because they literally crank on them way too much. This one here is a M4 screw that threads into the aluminum heatsink, so you won't have that problem there. But nevertheless, it's not over cranked. It's all very flat. It's just a witness mark on there from the stud. All right, so on the bottom side of the board, the only other thing I really care to show you is right over here. And I did this, so whatever that is, I think that's the inductor, and that's a capacitor, and that's a capacitor. So these weren't soldered in all that great, so I just retouched the solder pads, that's it, with my soldering iron. This one here, this capacitor was standing up from the board by about 1/8 of an inch, so I reheated these 2 solder pads and pushed the legs through the board so that the bottom of the capacitor would be flush with the board, so that I could then add silicone to it to secure it, and also resoldered. And I did not wash anything. So as a result, you can see a little bit of flux on these ones, but you can see a lot of flux here because I definitely resoldered these ones with new solder. And as you can see, look at all that flux I left behind. Yeah, there you go. There you go, 160 volt cap right there. So that's the high voltage side. And yeah, look at all the flux right there. So I did this on purpose. I didn't wash the board so that you could see what rework or repair work looks like. And you do leave flux residue behind. This is flat out the nature of the thing. It's why it is you wash your boards afterward with, you know, alcohol or xylene or some other solvent that's going to wash all this flux away. And if you look at my Rush controller, you know, I did those teardown videos for it, the one that I bought, and it's covered in flux just like this all over the place. That controller has seen massive repair work done to it everywhere. Fluxes on all around the surface mount components, fluxes all around all the capacitors on the bottom. You see this everywhere. So, you know, Christopher Kleinschmidt can lie all he likes. Proof is in the pudding, guys. This is work that I did and did not clean up, and you see that all over the place on my Rush controller. If you need more proof that Christopher Kleinschmidt is lying to you, well, here you go. There it is. All right, so that's pretty much everything I want to show you on here. All these caps were hand soldered. You can see how the legs were all clipped off. Actually, that might not be. No, actually, I think that's wave soldered. Yeah, look how consistent all of those solder joints are. That's all wave soldered. That's not hand soldered. Let's see, anything else like that? Yeah, look how consistent those are. So the parts were put in the board, and then this was put through wave soldering. That's the only way you get those really consistent solder joints like that. Hand soldering, you get less consistency. So good job, Far Driver. Of course, you don't have anything on the bottom of the board like, say, Komodo does, so you can use wave soldering here. In fact, Yeah, that's all wave soldered too. So they put the parts through the board, and then afterwards they come through and they clip all the legs off, because you can see that these legs are all cut off with flush cutters, but the solder pads are all covered very consistently. This is very common for wave soldering, which I have talked about before. And well, KO can't do that with theirs because they got junk on the bottom of the board that they have to get around. You know, connectors, they got the Bluetooth module on the bottom, stupid shit like that, which they don't really need on the bottom. They could do that differently. And, of course, flux all over the place. Yep. All right, folks. I think that's everything I want to show you about the logic board for the Far Driver 96850. And the next video will be the power stage.